Welcome to Build with Naz. My name is Naz. I'm the founder of Rebel and the author of the Rebel Open Core repo, which contains a lot of text user interface crates in Rust. So if you're interested, check it out here. In today's video, it's going to be a live coding video. I wanted to go over the details of using the Diesel ORM, Object Relational Mapping Software crate, along with SQLite, which is a embedded database that you can run in process that's written in C or C++, I think. Actually, let's see what it's written in. Where is it? It is written in C, not C++. Excellent. So there's actually two. This example that I'm going to be building from scratch, there's actually two parts to it, and this video I'm not going to cover the simple, quote-unquote simple version, which is using something called rusqlite, which is a very simple crate that allows almost direct access to SQLite. So you can think of it this way: you can, if you wanted to connect to a SQLite database, let's say you can have this database running in memory or stored in a file on your local file system. In that case, you would just use rusqlite to generate the SQL statements as strings and then execute them directly. So basically create a prepared statement, run it against SQLite, get the result set, and then do what you need to. So I will walk through the source code very kind of in a cursory manner, but it is available on the Rust Scratch repo. So if you wanted to check out the rusqlite in detail, that is available. So, but what I want to focus on in this video is Diesel. And the kind of example that I've picked is going to be the same between rusqlite and Diesel. And that is, we're just going to make two tables. One table is going to contain text formatted many rows. Each row will have a column, which is JSON data, basically text formatted JSON, a serialized JSON string blob. And another table which will have a vec of bytes. In other words, we're going to copy a bunch of bytes from a file and then actually put it in a database. So the schema will reflect that. And yeah, so that's essentially, and we're gonna implement CRUD operations, create, write, update, and delete operations on this embedded database. And also because Diesel specific things we're going to talk about, and I'm going to show creating migrations, which are really handy. So essentially you tell Diesel how to version your database so that you can change your schema over time and then do it in a non-destructive way. And then I also have a script that I wrote which automates all of this. And then there's other things I'll show at the end as well where you don't even need to use some of these manual tooling to set up the database, to migrate databases, the data in the database, because all of that can be done programmatically. And yeah, so that's essentially the outline for today's video. And with that, let's get started. So one of the main reasons for me doing this video and actually using SQL in the Rebel Commander product or repo is that I've been saving settings files. So essentially a bunch of key value pairs are being saved to files, and that's okay if you only have one binary, let's say one process for your binary running at any given moment. But as soon as you have multiple of them, it's very easy to get files to get corrupted. You can have two processes for the same binary writing at the same time and doing all kinds of other awful things because, you know, files are not really made for that purpose. SQLite has a benefit that it actually does support multiple processes. So essentially, you can have a database file on your hard drive, your SSD, your local file system, and then you can have multiple processes for your same binary concurrently accessing that database file. And so for reads, SQLite supports concurrent reading, and for writes, it'll lock, so it'll only allow one writer in at a time. So that's kind of handy. So there's another alternative over, let's say, instead of using a relational database like SQLite, you could use a key value store if your data is just mostly hierarchical. And there's a nice crate called SLED that does that. And so let's see this one. Actually, where is it? This one. And oh, actually, it's the same one. Let's see. And yeah, in the Rebel repo, where is it? The Rebel open core stuff. So many tabs. This one. There's a crate in here called Rebel Core, and I actually have a KV module, which makes it very easy to work with SLED KV stores. So that might be of interest to you if, actually, what is this? I'm trying to use this to navigate tabs. That's not really that helpful. Where is SLED? Ah, it is helpful. Ah, there we go. Okay, so this is a key value store, and I think, I'm not sure, but I don't know if this is multi-process safe. Let's see. SLED does not support multiple overlinks for the time being. Duration totally safe. Oh, please keep SLED open for the duration of your process lifespan. It's totally safe. Oh, okay. So every operation is thread safe. I see. So I guess, yeah, another benefit of using SQLite, because this does work for multiple processes accessing the same database file, basically multiple processes of your same binary. So with that in mind, that's kind of like the why of using a relational embedded relational in-process embedded relational database instead of using like a KV store or even just writing the files, which is I don't know, just prone to it's like collecting technical debt pretty quickly with file system storage for this use case. So one thing I wanted to show, there is a repo in my Rust Scratch repo on GitHub. There is a project, a crate called SQL, which has the code for all of this stuff in it. What I'm going to show first is just the simplistic rusqlite version, and then we'll do the proper thing with Diesel, create a new project and everything. So if you look at the rusqlite example in the source directory for the SQL crate in the Rust Scratch repo, there's an entry point, and it basically creates a connection to the database using a constant, which is just basically a path for the file on your hard drive or your SSD, whatever, or your file system. Should come up with a consistent way of saying it. On your file system, your local file system, and then or it could be remote, whatever, your file system, because you could technically mount like a remote folder using SFTP or whatever. Anyway, so yeah, so here there's two examples. One is a table, basically a module that manipulates a table which contains actually, let's go through this real quick, because the same kind of thing will happen in Diesel, so we'll do a deep dive in the Diesel one, but this is just to kind of give you a cursory look. So here, actually, why is this? Oh, that is zoomed in. Wow. Actually, let me see this. There is actually a way to fix this so that the minimum font size isn't so small. So let's do 14. Does that make it better? Yes, it does. Okay. So here, as you can see, the SQL is literally just a string. So create table if not exists, and then that's just, I'm just using just a format argument for the format macro. So the data table command, data table name is just like a constant, which is a string. So it's just replacing that. It's a template string literal, essentially. So that's just using format args. And then essentially what it does is it first creates a table, then it creates some struct, which has the struct is just this thing. It has some raw JSON data, which is just a string. It's not a blob. Like a blob is a specific SQL column data type. This is just a string. It's just text in SQL parlance. And then so that string essentially is contains just JSON serialized string, and then that gets dumped into the database directly, and you can use this record struct. When we go to Diesel, this is called a model, and this is the schema. So there'll be nice names for everything and more formalized definitions of all of these concepts. Like instead of just creating a table, we'll call this a migration, and then there'll be a schema attached to it. And instead of just this struct in here, which is just basically hand coded, we will have something called a model that we will use. And there's a whole bunch of derived macros from Diesel that make it easy to manipulate it and make sure that it doesn't go out of sync with the schema. A lot of compile time checks and stuff, which is nice. And I'll also talk about why Diesel and not SQLx for this particular video. And then, so what it does, this code does, and essentially we're going to following this exact same algorithm. So we're going to insert a bunch of records into the database here. Naively, we're just doing it, straight up with strings. And this is, by the way, rusql. That's how this works. Params macro. It's all rusql stuff. Sorry, not rusql. rusqlite, whatever. This one, rusqlite. And then this into diagnostic stuff is miet. And yeah, then after a bunch of records get inserted, the code just reads them. So basically, it's a select statement, and then it just prints them to the screen. But the little thing is that it converts or parses this whatever is in the raw JSON data column of the database. It parses it as a SERDY JSON value struct. So essentially just a key value store, a JSON object essentially. So we're parsing it, and then it displays it to the screen. So that's literally it. There really isn't much to it. It's just handwritten SQL. If you have a typo and you put a different table name here than here, it's not going to work. If these don't match up with what's in here, it's not going to work. If you change the schema over time by renaming a column or dropping a column, it will probably fail. And if you change the schema, this struct is completely unaware. And so are all the other statements. And these are all reasons why ORMs exist and why Diesel is a thing. And so actually I consciously chose to use Diesel instead of SQLx for just one reason. Diesel has really fantastic compile time error messages. So it's very like static compilation heavy. It can be a bit annoying if you want to do something and quickly. It's very strict about what you cannot do, which I appreciate because I don't want things going out of sync and having issues at runtime. So I'm glad that they have really good compilation checks. One other benefit is that actually, how do I put this in dark theme? No idea. Sorry about the bright screen. How do you put this in dark? Seriously? Interesting. Anyway, but so here actually, if we look at the main reason for using Diesel over SQLx, which is also very similar, is that I didn't want there to be the requirement that a database server is running at build time to validate the schemas and the models and whatnot. So that's why, and I also have a huge bias for domain-specific languages. I love proc macros, as you probably know from my proc macro guide on developer life. It's all over the place in the Rebel Open Core repo. I mean, I've learned to sort of use them judiciously and not just because they do add extra time to compilation. But yeah, but declarative macros actually are pretty powerful too, and they don't have that compiler tax. Okay, so it uses a domain-specific language which allows to check for dynamic queries, so which is really nice. A lot of checks, static checks. So I'm happy about this. So that was basically it. I don't want to require database, and I wanted a lot of static checks for complicated queries and stuff, because I don't want to keep it all sort of straight in my head. I want the tooling to take care, actually let me know when I've, you know, when I'm about to release a bug instead of a feature. So let's see. Okay, with that said, let us create a new crate and get all the imports going and start building the whole Diesel project. So I'm going to start by creating a new crate actually. So let's do this. Let me say cargo new bin. Yeah, let's call it SQL. And then we can say code insiders, and this will actually reuse this window and open that crate in here. And the first thing, actually, I'm going to follow my own tutorial to some degree, just for these setup pieces. So I think the first thing we need to do is, let's see. Okay, let's go get the dependencies that we will need. And actually, I'm going to go ahead and get all the dependencies because let me see. I think there's more that we'll need than this. So I think one of the things we need to do is we only have a single binary, so I think the main function will be pretty straightforward. Here we go. These are all the dependencies that we're going to need. So I'm adding a whole lot more than just the minimum Diesel with a bunch of feature flags. For JSON parsing, I added assert for colorizing console or terminal output standard out to standard out. I imported cross term. These are just for generating some IDs. And then this is we won't need SQLite because we're not really using that here in this example. Chrono is actually when we add timestamps as part of the database migration. One of the migrations is going to be adding a column which has a timestamp. That's for later. And this is for you'll see initially we're going to use a lot of command line tools to actually get this working, but eventually we'll do all the migrations automatically. Using there's a crate actually in Diesel for that. There's also in this repo a script that I have created. Let me see. How do I should see? Duplicate. There's a nice script which outlines all the different tools that have to be installed. So the first thing we need to do is this is for the command line interface application for Diesel. We need to install libsqlite 3, and then which is basically just if you're on Linux, you just do sudo apt get or apt install libsqlite 3-dev, and that's that one. And then we also install the command line tools. These command line tools are necessary for creating migrations, not necessarily executing them. So it is necessary to have them. And so you can look at the fish script in that repo, and it basically what it does is cargo install diesel CLI, and it passes a feature flag, and it says feature flag is SQLite. So that's basically essentially the command looks just this. So we do cargo install that. It's already installed, so if I hit enter, nothing will happen. And then this one, libsqlite. These are the two dependencies that actually, let me go ahead and put that in a README here. So essentially what we need to do is prerequisites as prerequisites, we have to install both this one, and we have to install that one. So this gets the actually, let me get rid of that spelling error. So this is this gets the SQLite binary for this is necessary because the diesel CLI program actually needs it, and we install that using cargo install. And once that's done, we can actually run the diesel command that's now available. So we can do diesel help, and there's the command basically. That's the diesel command line interface. So in a diesel project, now that we have our imports sorted, and I'll go through the imports real quick. So SQLite support is one of the feature flags. This is optional. This is for a flavor of SQL, where when you mutate a table, if you want to get the results of the mutation back, then it's called a return clause. A lot of times you'll just get the number of records that were modified as a usize, but if you wanted the actual records, then you can enable this and use the returns clause, which we'll see an example of that. And the chrono, this is for using Rust chrono create and mapping it to the timestamp SQL column data type. So that's what this is. So with that, now that we have our prerequisites done and we have the toml file imported, the first thing we're going to have to do is specify where our database actually lives. So to keep things easy, I'm just going to, in my current working directory, which is this folder, I'm just going to have a database file called diesel.db that I'll be using in this entire example. So nothing too complicated there. There are a couple ways in which we can specify this. One is in the application, we can just either, as a string, we can either pass the database through the command line interface, like through clep, or we could use a .n file and use the .nv crate to load that. We could also just use an environment variable. And this third one, I think I already mentioned, we can pass it directly as a command line argument. So when you say cargo run, actually, I think it's just cargo run because we don't have any. Let's see what our main program is. I think it just says, oh, by the way, if you wanted to get the extension that I have in VS Code, which automatically generates these copyright headers, I think that's why I had this open earlier. Yeah, there's this VS Code extension that has gone unmaintained for a long time that I forked and essentially rewrote and modified a bunch of it, and I made a new one called auto insert copyright. I haven't published it to the marketplace yet, but if you want, you can just get it by going to the GitHub repo. It's github.com rebel.org auto insert copyright, and it's just a handy little extension to here. This is what it does. Automatically inserts copyright, so just a headache otherwise. So this one automates it. Anyway, so let's see. Let's go back to our. Okay, so now that we have, actually, let's say let's diesel. Let's say run diesel example. So yeah, so that should be, there you go, run diesel example. Excellent. And remember I had the this create cross term, and I said it was for colorizing output. This is the kind of stuff we can do. We can say something like that, and then we can bring this in. This is the cross term. So now when or whatever, magenta, I can do magenta, I can do like bold, I can do underline, underlined, and then if we run it, you can see what it looks like. So it's there. If you don't like all the noise, we can do this. So basically that's what it looks like. Run diesel example. So that's what the cross term was for. So okay, so the first thing we got to do is we have a main function, which is great. We have all the imports, but we don't have any migrations. So the first thing we got to do is we have to get the migration set up. And the migrations are a fancy way of saying that we want to timestamp a folder, create a folder with a timestamp in it, in which we specify the SQL statements that will create our schema and the SQL statements that will take down the schema. So basically a constructor and destructor for our schema. And so the first thing we can do is we can say diesel. So this is the diesel command line, the CLI application. So we can say diesel database equals diesel DB. So that's, and we can just say setup. So if we say setup, notice that it created a migrations folder and it created a diesel DB file. So I actually have another extension. Let's see, I think I listed this. I think it is all the way down there. Yeah, so I have another extension called, actually there's two extensions. These might be nice to get. There's one called SQL formatter, which just uses the a node package to, it just runs a node package. The node package is called SQL formatter plus, and it's just a VS Code extension that ends up turning around and calling this node package. It's very similar to the prettier VS Code extension. The extension doesn't necessarily do the reformatting, it calls this other package which does the reformatting. So that's worth, I think, installing. So it automatically, you have to install Node for this, and then it'll reformat the SQL, which is nice. It's kind of like prettier for SQL, or Rust format for SQL. Oops, I think I overzoomed it. And this one is also nice, the SQLite viewer. It's a nice little extension that allows you to very quickly see the contents of a database like in VS Code. So I just double clicked on that diesel DB file and noticed it's empty. There's nothing in it. But there is something, a diesel schema migrations table with a bunch of columns in it, which we don't know what they do. But that database setup, when we said diesel database URL diesel DB setup, that ended up creating that database file, and it also created a migrations folder. Notice there's nothing in the migrations folder, so it's not really doing anything. And so there's also nothing in keep. So the next thing we have to do is we have to create a migration. And when you create a migration, you have to give it a name. And when you do that, it'll create a folder with a timestamp with that name in it, and it'll also generate an up and a down SQL file in it. And let me see, migration, and we can say generate, and we can say, I think let's call it create new tables. So this is, it doesn't matter what we call it. Notice it created two files, migration, some timestamp, and create new tables up and down SQL. So let's go look at up and down SQL. So if you look at the diesel database, it's still empty. There's nothing in it. So in these migration, the SQL up and down SQL files in the migration directory, the intention there is that whatever we put in up, whatever SQL we put in up, when we run the migration. So we created a migration now. We created a migration or generated a migration. When we run the migration, it'll actually take whatever's in the SQL and it will put it inside of the DB file, which is pretty handy. So it'll mutate the DB file with whatever we put in the SQL. So for example, if we wanted to create a table, we could do something like this. We can say create table. Actually, we don't even care about if it exists or not. We can just say, let's see, we can do, so we can just say create table, data table, and we can also make another one. You can say create table, file table. And in the data table, we can have like an ID, which is text. It's a primary key. It's not null. And then we can have a name, and we can say text not null. And we can have data, which is also a text not null. So this is essentially a data table which has an ID and a name. These are all going to be not null. And it also has a data. And this data is where we're going to put that JSON string. So here we're going to do something very similar, except that here, actually, let's see. I think over here we want not text, but let me see. I think we have to do like a blob type. Okay, so we do need a blob type, and so I think, let me see. Let's look at the docs real quick for Diesel. Actually, Control-Shift-A is a nice thing in Chrome. I don't know why I don't use it more. There we go. Oops, Diesel, this one. So I think it's called SQL types or something. I think binary. So binary, okay, yeah, that's right. So I jumped ahead a little bit, but essentially whatever we put in here is going to be translated, or it's going to be converted to Rust code by Diesel. And this is, you can think of it as a conversion table. So here we say data is the name of the column. Fortunately, the syntax highlighting is less than optimal in VS Code. I don't know why it's colorizing this so strangely, because in Rust Rover it works just fine. So I don't know what the heck is going on. Like this is not the correct syntax highlighting. Let's see, SQL syntax highlighter. It should look something like sure. Let's try that. Nothing? What the heck? Why is this not working? Oh, that's terrible. Wow. I guess I could just use Rust Rover. Actually, let's see. Just so we can see what the correct syntax highlighting looks like for this. Actually, let me just open a new project. Downloads. What is it? SQL? I think we had it. What is going on? What? GitHub. Seriously? I thought they fixed this. That's very strange. This is one strange thing about, let's see, downloads, SQL. Okay. Let's do this window. Okay, so this is actually what the correct SQL is supposed to look like. If, what, migrations, let's see. Yeah, I mean, that was a lot of work just to, what the heck is this? Data sources? SQLite, I'm assuming. Okay. Huh. Think, wow, that was a lot of work just to get some syntax highlighting. I think, I don't know why this is complaining. Change SQL dialect. Oh. Oh. I wrote my SQL wrong. Oh my goodness, I see. Thank you, Rust Rover. As you can see, I do not work a lot with SQL. And let's see if we do format. Actually, this is not going to be text. This has to be blob. Yeah, that I think should work. There we go. Okay, now if we say Diesel, Actually, let's look at some files real quick before we run the diesel migration. So there's actually a diesel.toml, and this is where once these SQL migrations are run, a source file will be generated, and this is where we get to specify where that source file is actually dumped. So here it's dumping in the source, and then just root level schema.rs source. Yeah, that should work. So it'll be beside main rs basically. That will work. I guess we could do we could add librs here as well, and then what the heck is this? New Rust file librs. Okay. Yeah, and then in here we could well, and then we can bring in the, once we run the migration, actually let's go to VS Code again. So here when we, okay, so now we haven't generated a by the way, when we were in the diesel setup is when it created this diesel.toml file as well. So the thing we have to do once the migration has been created is we have to run the migration. And we run the migration by running this command. So, and that should generate the schema. Actually, let me put in a down. A down SQL is the SQL that will be run in order to destroy, it's a destructor. Like this is the constructor and that's a destructor. You can think of it that way. So we got up will create it. Actually, let me zoom in. So IDE, there we go. Does it match the other one? Yes. Okay, so here, let's see. I think actually, what is this? Oh, let me look at the settings real quick. I don't know why the fonts are all wonky. What is going on here? Okay, there we go. It's a different font for some reason. Okay, so here, when we, let's see. Okay, so this is making sense. Okay, so here we have the create table, data table, create file table, and then for down we'll have drop table. And I don't need to say if exists, I can just say go ahead and drop this and then go ahead and drop that. So this will, or maybe that's why it had exists here. No. Oh, okay, I see. Well, maybe we can put that create table if not exists. So we can put like this, something like that. So create table, I think that's the correct syntax. Let me see, create, pretty sure, I think it's create table if not exists. Yeah, okay. So let's see if this worked. So now we can say diesel, and we can say migration, not redo, but run. Redo will only works if you've executed run at least once. I've run into this problem so many times. Like redo will do nothing. Actually, I should probably make a note of that in the README. That's kind of important because it's kind of like I've run into this multiple times where I'll run redo, but nothing actually happens. Let me see, where is this section? This is here's the up SQL, then execute the migrations. Okay, let me just update the README real quick while I'm here. So this imposes, okay, so I should say that note that the redo command does not do work unless the run command has been executed at least once. And I think also, just to be safe, it is also best to delete the diesel DB file before running, in order to do a complete reset. In order to do a total reset and then run, and then redo, just to be safe. So let me commit this real quick and then it'll show up in our README. let's see, what is this? SQL update readme. Okay, I was just updating the repo just so I don't forget. That's weird. Why is this not working? Okay, it's weird. Okay, now that that's updated, I think I'm just going to hit refresh, and here are the notes I just added. Where did it go? Here it is. Note that the redo command does not work unless the run command has been executed at least once. Okay, we've run the setup command, and then the setup command created the DB file, which is empty. What is happening? Oh, this is Rust rover. And then it created the diesel.toml file, and inside the diesel.toml file is specified where the schema.rs file is going to be generated once we execute the run command, and the run command will basically take whatever is in here and actually just up SQL, and it will run it, generate the database schema in the DB file, and also update the schema. So let's see if that worked. There's a schema. I didn't oh, this is good actually, because this needs to be attached files, so we can say mod schema. That should work. And let's look at the schema. So there we go. It was generated automatically by Diesel command line, the CLI application, and note there's binary. So essentially whatever is an up blob, it gets put in the schema as the output, which is really, really cool. So this is the object relational mapping in Diesel showing itself. So, and yeah, so there you go. There's at least the first part. So now if I say redo, so redo will actually run down, drop the tables, and then it will execute run again. So if I say redo, we should have no difference, because our database was empty and it just literally dropped 2 tables and added them right back. So our schemas is unchanged. And so there you go. There's always plugin updates. So that essentially is the very first phase. So now we have the setup of the migration. We ran the migration that generated the schema. And now that opens the door for us to do something with that schema in Rust land, because so far we've been generating the schema. Let's see. Oh, this is nice. What is the difference between redo and run? Okay, cool. Location. Oh, excellent. This is all stuff that's really good. So like for us, the default is fine. Like the schema is generated in source schema, but if you have a more sophisticated folder structure, then that might, you might modify this to suit your needs. And then let's see, for the current migration, oh right, and every time we change the up SQL and run it again, it'll regenerate the schema.rs file. So that's pretty cool. Actually, what happened here? I feel like the theme changed. Yes, it did. Why? That's weird. I don't know what is going on with Rust rover. Let's see. That's just a tokenized storm. Cool. Okay. Let's go back to here. Okay. So now we are at a point where we have our up SQL, we have our down SQL, and I can't believe I made the mistake of using curly braces here. And it shows you how often I write SQL by hand, or I write SQL at all. And then thank goodness for Rust rover. This has a really nice database plugins and stuff like that. Let's see. Actually, I wonder why. Thought I installed this copywriter thing. Huh. Interesting. It's supposed to be automatically. Oh, I don't think I have it set up because it didn't put the copyright. Actually, it put the copyright here, but it didn't put the copyright here. What the heck? Let's see. That's weird. That is very strange. So that works, but it doesn't put the copyright in the SQL files. Oh, okay, I might have to actually update the plugin to because the comments it's that won't work. It has to be like this. Oh, I see. Never mind. So I see. So I might actually have to update the copywriter plugin to handle SQL file extensions with a special template. But I will deal with that later. Okay. Interesting. Okay, moving on. Let's see. We don't need the copyright for up and down. We can just drop those. I don't know. Okay. So we have up, down, and then I think we have our schema. So excellent. This is binary and that is text. Those are the two things that I wanted to double check. And then we did a lot of these steps manually. In the actual project, I have this script, this thing, diesel setup. So if you run that, it just takes care of everything. It's pretty smart. It checks to see what the state is. If you run setup, if you have run setup, it asks you if you want to run migrations or if you want to generate new migrations. So it's pretty nice. One day, I actually have plans to create something called Toolify, Text User Interface Lite. I want to be able to make it so that it's easy for scripts like this to prompt users to choose from a list of options, and then select one and then return it to the shell program or whatever the shell script is that call that binary to get the user input from the user. It could be an exit code or something, or I could just echo it to standard out and read it in from there. But yeah, that's something that I have on my to-do list, because these scripts are getting really complicated. And yeah, I have a bunch of other videos I'm going to record for machine, like kind of productivity setup and workflow and things like that in Linux. And I'm going to start and actually stop using fish and start using Rust to make scripts, and then lean into a lot of these TUI crates that I also maintain and build to make sure that it's just easy to create these sophisticated scripts in a type safe and manner that makes it easy to, let's say, bring in modules, and also just easier to understand what's going on. This fish script syntax is pretty obtuse. Okay, so I think now that these have been created and the schema exists, I think the next step is to do something with it, and that's called actually, we're going to come back and do this migrations thing later. But what we're going to do now is we are going to, let's see. Oh, actually, this doesn't say anything about generating the code. It's just migrations. So let's see. Where's the... Huh. Doesn't say anything about the code. Interesting. I thought I had a section on diesel and... Oh, I see. Okay, just links directly to the example. Okay, so I think that was it. We don't really need to follow this guide anymore up until like now. Like we're good for now. We'll come back to this later. Okay. So now that we have the schema, the next step is to actually create structs in Rust, which allow us to manipulate the schema. And then we will write some queries using Diesel that then connect to this database using the schema, and then insert stuff, pull stuff out of the database as those structs, and then we manipulate those structs in Rust. So that way we're not really, like this is the end of our SQL manipulation. And from this point forth, we will now transition into Rust land, which is pretty cool. Because I don't particularly, I'm not a big SQL person. So so now let's make a new module, and we will call this mod models. And so models are, so schema is the SQL to schema.rs, and this is the Rust code to manipulate the schema, basically the database. Oh, that did not work as intended. What happened there? There we go. So we have, the Rust code to manipulate the database, and we have the SQL too. So, and this is generated by, we can say also generated from .sql files using Diesel. And these are the migrations. So the migrations right now we ran them manually, but by the end of this live coding video, we will run them programmatically, so that we don't have to run that Diesel, migration run command. This one, run. So, and you can run it like any number of times, because like once it's run, like we can redo. So basically what this does, it drops the tables and then makes them again. So if we look at the database table, we'll see that now, in addition to that meta table, we also have a data table, which has an ID, a name, a data, a file table, ID, name, data. And so yeah, and this is we did this basically from Diesel. That's pretty cool. Wow, very nice. Okay. So let's close this viewer. Actually, one of the projects I want to build as well in the terminal is a SQLite viewer. I think that would be pretty handy. Okay. So now that we have this models thing, we're going to create a data structure for each row that maps to a particular table. So you can think of a table as relational, so there's rows and columns, and it's typed, hence the schema. So if you look at our the schema rs file, you can see that essentially we're going to tie these two together, so to speak. So we're going to have a struct here. So actually, let's do this. We need this first. So that pulls in a whole bunch of dependencies that we need for Diesel. So we are going to do something like this. We're going to say pub struct, so we have a data table. But by the way, this is a proc macro, obviously. So this ends up generating some code, which is great. And so now this part isn't generated by this code. This part we got to generate by hand. So here we can say we got that for the data table, we have a record. That's kind of like naming convention I'm going with. And that's essentially correct. We have pub struct file table record. And so this is actually, this is it. Like we've done the sort of, this is the relationship between the data table record and the data table, is that the data table record has inside of it ID, name, data. This has ID, name, data. So this is really cool. So let me see. It's a cargo build. This should build. Yep, it builds. And let's just do a commit real quick. So initial. Okay. So now that that's committed, obviously the program doesn't do anything. We can do cargo run and doesn't do anything, but not yet. So now these structs are, if you want to think of it this way, they're like floating in space. Like they don't floating in space. They're not really tied to this or that. So that's the next step. Like we have to kind of bind them manually. So there's a bunch of these attributes. I'm going to copy the documentation and dump it here because this is really useful. So there's a bunch of derived macros that come out of the box with Diesel, which are really, really useful. And there's things like queryable, selectable, insertable, and these generate a bunch of code that end up making it so that our Rust struct and the schema.rs generated code work nicely together. And we'll see where these come into play in a second, but I just want to introduce them. So the first thing we want to do in our data table record is tell this Diesel that the data table record is actually bound to the data table. So essentially we want to do something like tell Diesel that this struct can be loaded from the data table. And so in order to do that, we have a Diesel macro that says something like table name, and it's not data table as a string because that's not, we can't really type check that. So so what we want to do is we want to say so we want I think the schema and is that, yep, data table. So this okay, what is wrong with this? Cannot find, what is this? Not model schema. Oh, I think I'm supposed to do other, oh, actually this is correct. Your Copilot was correct. You have to first say derive queryable and then put these attribute macros in there. So this one is basically what we're saying is that this structure can be used to do queries, which is this thing, from this table. So now if I put like something strange here like U32, U33, let's see. Oh, that should, wait. Oh, I don't think I've done enough. So basically, let's put a bunch of these in there, and let's do this. There's another thing that we could do. As you can see, when I put like, actually, let me do this in steps. So we put U32, or let's do this back of U8. That should just, let's see if the compiler blows up. It does not. So as you can see, I can put whatever in here. It doesn't seem to be making any difference, right? So I can put like F32, and it seems to be, it's like magically it doesn't, it seems to be fine with everything. So the reason it's fine with everything is because this attribute hasn't been added. It's this is really, let me grab this actually and open this here. So this one, what the heck? So this optional type attribute. So this thing hash diesel, like we've seen this hash diesel table. This is all from the prelude, and this is, it says selectable, but I think we can also say queryable, so we can say selectable, that same thing. Actually, there's like a bunch of these we're going to add, like queryable, insertable, as chain set. This is for different, like this is for the select statement. That's for, I think also select statement. This is for insert statement, and I think this is for update statement, something along these lines. So so it goes to implement selectable. This derived needs to know the corresponding table types. So that's this table type, table name, create. And this is the code that was generated, by the way. That's what this is that the schema file that was generated by the diesel CLI. That's here, which is pretty handy. And then we can say something like the type attributes. That's what we already used, the table name, and then we're going to add another one, which is this one, check for backend. So this instructs the derive to generate additional code to identify potential type mismatches. And this basically supercharges the warnings and the errors that we get from the compiler. So what we want to do is put this here, and we are going to say not Postgres, not MySQL. We're going to do SQLite. And if you look at the cargo.toml from earlier, let's see, we had features here called SQLite, and that's what this is. So it's really nice. That way we don't have to import like SQLite binary or anything like that. That's taking care of it for us. Like I don't have to get another crate where I pulled in the SQLite binary itself. So that would be added to this this binary. So this binary is in target. Where is it? Target SQL. There it is. So inside of this binary, the SQLite binary is in there already. That's the elf. Yeah, binary. So anyway, so we can do target debug SQL, and that runs our program. Okay, so let's see. So now that we have this compiler error message and stuff like that, here if I say U32, notice it blew up. How cool is that? So I can't just put anything willy-nilly. Like it's type checking. It's saying that you're telling me that this particular struct corresponds to a row in this table, and in this table there is a data column whose type is text, and you're telling me it's F32, and it's immediately giving an error message. This is fantastic. So I can't mess it up. So I can't put like that doesn't work either. So it's gonna say like there is no X data. So this is awesome. This is like the benefits of using Diesel and getting all the nice rich compiler static analysis compiler errors. So similarly, we can do the same thing for the file table record. Only this one is going to be actually this one. So because this is check this out. Because this is Rust code, we can do this, and that will work. Because it's the schema.rs file was generated and put into our source directory. So now I can do stuff like this. So this one is going to be file table, and here the data is oh, of course, it's saying that for data table there is no such thing as data of vec-u8. It's because it's in the file table. So, and as you can see, the errors went away. So that is really, really cool. That's probably one of my favorite features in Diesel, is that it won't allow me to get the mapping wrong, and that way it's one less thing you have to think about. So let's commit this. We've done the implement or whatever, add schema.rs and models, model rs. So we have that. So now that was, let me see, let me keep these side by side actually, which is easier to read. You know what, I'm going to go back to how it was. So we have the schema that was generated from the SQL, and this is Rust land where we can do whatever. So normally we can just use string and vec of u8, and this is a very minor detail. Like these are going to be clone. That means that string is on the heap, vec is on the heap, and basically when the database pulls it out of whatever binary representation it has under the covers through whatever database driver it's using, it's going to copy that and put it in the struct. So if we didn't want to do that, we could do something, and this is really minor, and if this part is confusing, then just stick with whatever you see on the screen right now, but this is another way. So here we can do something like, let's say we introduce a lifetime here, and instead of string, we can say that. So basically we're saying, that instead of allocating the string, if you can borrow it, then go ahead and borrow it and put it in copy and write. And there's this whole pile of conversions, transmutations, or whatever you want to call them, that Diesel implements. I think where is it? It's like Diesel, this one, SQL types. You can check this out. This is really cool. There's a whole pile of conversions that happens between, like Diesel does a lot of this stuff. So one of the things it supports is copy and write for str rather than the string, the allocated strings. So this is pretty cool. For string slices, you can just put them in copy and write, and it also does the same for vec. So I can do something like, so the string ones will be like that, and for vec, it'll be very similar. We will do copy and write of backtick a evacuate. So now, yeah, we can do that. That is actually pretty cool. So now, when we do a query and we get data out of the database driver through its database connection, and then we access those records, we're not accessing them as a string, we're accessing them as copy and write string slice, because we're not really modifying them. So that is, and again, if this is too complicated, then just, this works too. So depending on your tolerance of the lifetimes and so on. I have a really good set of resources on lifetimes. So this one, yeah, subtyping and variants, and there's like a whole bunch of videos that I've done deep dives into, like lifetimes and subtyping and variants. So yeah, please check them out if you have questions about this. And I'm going to do some more actually on some more videos on object-oriented modeling for folks who are, like, let's say, familiar with Java or Kotlin or any other object-oriented programming language, and they want to do something OOP-like with inheritance and so on. So I have an example that I got to record a video on, which takes something like a view hierarchy you would see on an Android, and how to kind of map it to Rust, because there's all kinds of things we can do. But a lot of the examples I've seen don't really go that deep. It's usually some kind of animal that speaks or something, and that's about where it ends. But I came up with a much more sophisticated example, because a lot of what I do in the text user interface engine is view hierarchies. And so I took some of that, simplified it, and made an example, and I'm planning to do another video on it, or a video on it. So let's see. Okay, so I think, wow, so many tabs. Yeah, so I think that this is, let's see if it runs cargo build. It should run. Yeah. So here we have basically done replace whatever string and vec with cow off. Okay. And then so we have copy and write for those items. And then so now we have the schema, we have the models, but we haven't actually done anything with the schema or the models. I mean, we're not going to deal with the schema anymore. That was more like a one-time thing. So now we're going to write a program, basically put it in main.rs that will actually do something with this model, and then after that, we're going to do migration, and then we're going to update this example with that migration, and then basically we're going to do some CRUD operations. So we can put that here now. Perform CRUD operations on the. We have two tables actually. So we have data table and we have file table. So these are the two main things we have to do next. And then let's see. I think here we'll do like insert a few records, update them, delete them, and then print them all out, and then do it for both tables to see what that looks like. All right, so that's the next step. Then after that, we'll do migration and create another migration to add another column to this database that will change the schema and then update this code to accommodate that new column in both of these tables. So that is next. So let's create some records in the data table. So for this, let's make a module. So we're going to say pub mod, let's say data table ops, and we'll do another one, file table ops, but we'll come back to that later. Let's create this. Okay, so we have data table ops and file table ops. So in data table ops, what we're going to do is we're going to say data table ops, and we're going to say insert a few records, and that's our insert operation basically. So, and here we can say, oops, that's not right. There we go. And then where are we? And then yeah, so we should be able to. I'm going to close this. So here we can just return a MET result. I have MET in the imports, so I like it a lot. It's a really nice thing. All right, so let's see now. Okay, so here we can do like this, and what is the problem? Oh yeah. And then there you go. Okay. And then this will, our main function will also return MET result. Okay. So with insert a few records, what we're going to do here is that let us make a new record. So we can actually, because it's a data table record, we can do something like this. Say let new record 1 is this thing. We're going to import a data table record. I think this is, yeah. And then, so basically what we're doing here is that we're just getting the ID is going to be this randomly generated name, and then the name is also going to be randomly generated, and then the data is just going to be literally the just a raw string, which is just, in JSON format, key equals value with quotes and everything. This is just so that I can use quotes in here. That's why I did this. Otherwise I'd have to escape them, and that looks really difficult to read. So essentially now that's record 1. So let's do, okay, let's do new record 2, and there we go. That should be Jane Doe, John Doe, and then so now these are obviously in the reason there's into is because we did a copy on write, so it's converting these. This is a string basically, and it's converting it into this type. Sorry, this type. So copy on write str. So here we can, now let's do the insert operation. So we'll say let number of records inserted equals, we're going to say diesel. Actually, let's import the diesel prelude because that's important. So we can say diesel, and then we're going to say insert into, and so we have to now say like, okay, insert into like this thing, the data table. So here, because we can just use the use clause basically, or use statement for this, and then so let's see, we have diesel insert into that thing, and then what we're inserting is we're inserting values, which is like a vec of record 1 and record 2, and then we can execute that query. But before we execute, what we need is a connection. So we're missing a connection. So we're going to say connection, and then let's pass this connection in. And that connection's type is going to be a SQLite connection. And that's from Diesel. It's in the prelude. So one thing we need to do in the main function is we need to create this connection, and what we can do is we can say something like this, connection, and oops, and then that will, and the database URL is going to be for us, we can just hard code it actually. We can say const database URL is diesel db because that's how we had it, and we can say this. All right, so now we have a connection, and then we can pass that in, and mutable, let's do this, mutable reference to connection, and that should work. Okay, so then it takes care of our types, or no, it doesn't. Oh, right, so we were in the middle of I think inserting a few records. So I think this, it goes something like execute, and then we have to do into diagnostic. Yeah, so that's for me. It basically converts the error to a report that is compatible with this thing. And we're not returning anything, so that's why, yeah. I have a whole other video actually on Miet if you want to get familiar with that and you haven't used error reporting with Miet before. It's really nice, and I have a video on it as well. Okay, so let's see. So okay, here we have the number of records inserted. That's great. And then now we can let's see. Just print whatever records I think we have, or let's see. Actually, we can say something along the lines of, you know, this many records were inserted, and then let's do this because I want to colorize the word inserted, so we can do green for that, and that should work. Okay, something like that. So basically we're saying, okay, we have inserted this many records. So let's see if this works. So let's see, do we have a diesel DB? Yes, and it doesn't have any rows in it because we haven't really added anything. So now if we run the program, notice it says inserted 2 records. So now if we go to our diesel DB, you will notice that in the data table we have 2 rows that were indeed inserted. So this is pretty handy. So we can see, like, that's the ID, Bailey Raspberry something. The name is whatever, Undaunted Adjuvant. And notice the key value pairs are, that's just a JSON raw formatted string, or JSON encoded string, or JSON formatted string, or JSON string, or just, yeah. Okay, so that takes care of that. Now let us do, so that was the create part of CRUD. So now we're gonna say, let's do, what should we do? Create read. Let's do read last. We'll do update. Update, let's say the first record, whatever that means. So we're gonna do like this. So this is gonna return yet result of nothing. And we're gonna say okay. And so let's see, the first step is we're gonna do, so we have to find a record to update. So we can, and that maybe there, this first record exists, maybe it doesn't exist. And there's a way to do this in Diesel. It's called first and optional. So so we say basically, let's see, option, yeah. So this essentially tells, this Copilot is amazing. It just basically did it. Another way of instead, if you don't want to do first, you can also do like limit of 1, and then you can say get result. I think that achieves the same outcome. So whatever. First is easier to read, or it's kind of like the same kind of thing. So first is shorter. That's cool. Okay, so now we can say if let some whatever, then else whatever. So no records found. Oh, no records found to update. Why is that is strange? Both are red. Oh, so we can just, that's weird. To update and not red, we can just say gray or something. Okay, and what happens if we did find some records to update? How will we update them? So one thing we want to do is we're going to take the first record's name, and we're going to essentially add a star to the end of it. So we're just going to say like whatever it was, and then star, like that. So essentially that just updates it. And then what we can do is we can say to Diesel, we can say, let's see, let, so this is, I'm going to use a, there's any number of ways in which this can be done. So this one essentially just says, go ahead and update the record, find the ID, and then, you know, just take whatever you find for that ID, just replace it with the name of, essentially replace that record with this new one, and this new one has the only update, which is that it has a star at the end of the first record name. And then we should be able to say updated record, something like that. So basically, like we have the, actually what we updated was the name, something like that. So we have, let's see, updated, actually updated, we can say name for, and then let's do this for updated name with, and then, yeah, something like that. And then we can say for ID, and then we can put updated record ID. Wow, Copilot is really good for these kind of boilerplatey things. So now basically we're just grabbing the first record, we're amending the name of that first record, we're just appending a star to the end of it, and then we're just printing it up. So nothing really that interesting happening here, but that should work. Let's see. A data table record, returning. Okay, and then actually one thing we could do here is that, because we have that returning thing, we can say the thing that we modified, what we want to do is we want to essentially, the record that we modified, we want to, let's see, what is this? It's an alias for SQLite that can be used with it's an alias for SQLite that can be used with returning clauses. So this actually appends a returning clause to the SQL query itself, and this was this thing, returning clauses for SQLite. So apparently this is a new thing that got added with SQLite 3.3.5, and so I'm just using that feature just because I had that in the cargo.toml, just for no real reason, just to see that we can do it. So now if I do cargo run, it says inserted 2 records again, and then updated the name with, update the name with, actually let's do this, with, for ID, and then we can put something like that. So we updated the name. Oh, actually, why is there so many spaces? Oh, right. So let's do this again. So it keeps updating, notice, the first record. So even though like there's actually quite a few records in there right now. If we look at the, because we ran it so many times, every time I run it, it inserts 2 records. So notice that there's quite a few, and the first one, Bailey Raspberry 160, that just keeps getting updated. All these other ones are added to the table, but they're not updated. So it's working as expected. So now let's go and, so that was we did the create, we did the update, now let's do a delete. So, and then finally we'll do, let's just do last record, for no good reason. Actually, let's see, delete last record. Actually, I don't know if we can. Yes, we can, because we can order it by, this is where actually we're gonna, when we go to implement this, this is the reason for having that second migration, because there is no timestamp for when these things were created, and that's gonna make it difficult to delete items. So let's do this. Okay. So here what we want to do is, let's go see if we can find the last record. So we say let maybe last record. And this doesn't really make any sense. We're just grabbing the ID and we're sorting it so that the it's like from oldest to newest. And so the ID that was the newest will be shown here. It doesn't make any sense. Like the ID is not really sortable, so or it's not meant to be sorted. This is just random, and this exposes the need for having a timestamp, which we will address next. So I'm going to leave this here for now. This is like to do fix this with by adding a migration to alter the table so it has a created at column. That's basically the setup for doing the migration. But for now, we're just going to update something. Whatever this query returns, we're going to grab it and update it. So this is very similar to the other logic. So if basically, oh, why is this green? So it's record with ID, deleted record with ID. Yeah, so what we're doing here is that if we were able to find this last record, then we grab its ID, and then we give it to Diesel, and it generates a SQL statement to do the deletion, it executes it, and so on. So that should just work. And there are plenty of records to delete. So if we look at this, let's look at the table before and after. So Actually, why do I keep doing this? So we can just say diesel db. So if you notice, there's 9 records. So now when I run it, oh, what the heck? It'll still be 9 records because I deleted one of them, didn't I? So so I added one and deleted one. So actually, let's see. No, this viewer is not working, so I have to open it again. It basically, yeah, it wasn't live updating. I wonder if there's a way to refresh it. No, no idea. It's a SQLite viewer. Yeah, I have no idea. Okay, so yeah, basically every time we run this thing, we're gonna fix this. We're not gonna use this plugin for much longer. But as you can see, the appending is working and the deletions are working because it deleted a record with ID Molly Plum 301, and the first one has so many stars because we've been continually updating it. And finally, we're gonna do the read. So we're gonna say data table ops. We're gonna say print all records, which is essentially the read operation. And so you can say me at result. Okay, and then so here we're just going to be like, okay, get all the records, and then for each record, and then let's show the number of records, and then we're just going to say, all right, for each one of these records, actually let's do something a little bit more interesting. We can say iter enumerate. So now we have basically we can get the index and the record, and then here we can say something like let's do this. Let's make it a little bit more interesting. Where we have, let's say, ID, name, data, and the data. Actually, this is the interesting part because let's see, we have ID. That's ID. That's name, and that's data. So data, we're gonna turn this into a. This will work because the data is a string, but what we actually want is a JSON blob. So what we're going to do is let JSON data, and instead of, there you go. So what we've done here is that we've told SRD to basically deserialize the record data into a value struct, and then we're debug printing that value struct. So now when we run this, it should be like, in one line or whatever. So let's do this. So as you can see, it goes inserted 2 records, updated this one with the key stars keep every time we run it, adds 1 more star. It deletes one of the records, the last one, what it did by ID, and then yeah. So basically, and then if we run it again, it'll be 12 records because it inserts 1, deletes 1. And I don't think we need to display the record length. So that is the kind of like we got the data table working, but we haven't touched the. So this one is done. Actually, so we did the perform, but then now we're going to do update all these operations with the altered table. So we're gonna alter the table with a migration. So let's just commit what we have so far. We can say this is implement CRUD for data table. We haven't done it for file table, but that'll be next. And then, so here, now we're going to create a new migration. And in the new migration, we're going to add a new field to both of these tables. And we're going to migrate the data as well, because as you notice, there's quite a few, 13 items in there. So this is how we do it. We say diesel, blah, 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 migration, generate, add new column to both tables. So let's do that. And notice there's a new migrations folder with a new up and down SQL. And so here in the up SQL, we're gonna basically copy this. It goes something like alter the data table by adding a created at timestamp, which is not going to be null, and the default values is hard-coded number. So whatever this is, and then alter the table, file table, and this is because of data migration. So if we didn't have the default value with that timestamp with that hard-coded string, when the migration, the second migration would run after the first one, for those 13 rows that we've inserted, what were we going to put the created at timestamp value? It cannot be null. It has to be something. And so that's why when this alter table statement runs, it essentially fills any these 13 rows. They don't have the created at column. So this will add a created at column, and it'll put this timestamp in all of them. So that's one way, and this is going to do the same for data table, but for data table we haven't created anything, so this will run, but there are no 13 records for it to update. So and then also we got to do the corresponding down, and actually I think I found a little typo in the README actually, because yeah, it had the wrong data type. Oops. Let me see. Okay, so let's do this. So now the down is going to have basically, just drop the column, the created at column. That's how we revert this change basically. So that's the up and the down, and then we can run the migration. So we're going to run the migration, and so now when we look at the now let's look at the the DB file, and you will notice that there's a created at column, and look, it's filled in with a bunch of created at timestamps, which are wait, these are current timestamps. Oh, interesting. Oh, interesting. When I was messing around with this, if I didn't have one of these hard-coded number, it would complain, but it looks like it didn't even use it. It actually correctly picked the current timestamp. Huh. Let's see. Oh, this is why. Okay. I was like, how does this work? No, okay, so I didn't read my own instructions. So essentially, it did hard code those values in each one of those 13 rows. And then, very cleverly, it went inside of the data table, and it looked at where this hard-coded value, wherever it found a row with the hard-coded value for the created at column, and it replaced it with the current timestamp. So very smart. So unfortunately, there's no way that I could find of doing this in one step. So the process is that, yeah. So actually, this should also be run on the file table. This is not just for, and this is the part of the migrations, by the way, that I was talking about, where it not only altered the schema, but also handles the data, which is really cool. So actually, let me fix this. This needs to be, I'm going to update the README and the repo with this as well, because that is missing from what I have in GitHub. So let's see. Yeah, I mean, it was let's see. So basically, just add the same thing for. Where is this? Okay, done. I just added it to the Update the create column and data table and file table if needed. It's actually data table and file table if needed. Okay. I think that's pretty much it for this migration. Yeah, so the migration is handled in SQL. It's not, in this case, it's not, there's no Rust code that runs, so, which is nice. And let's see, let's look at the Diesel DB, and I think we looked at it already, it had the correct fields in it, so there you go, that worked. Wonderful. So now, now that we've changed the schema, notice this green, but you'll notice that the models haven't changed. So the models do not have what is necessary. So and notice there's compiler problems, which is good. So here, what we need to do is actually, let's do cargo clean, cargo build. Yeah, so basically, because their schema and our models have diverged, selectable, queryable, insertable, as change said, these aren't working because it's saying that, hey, you're missing a field. And we are missing a field. And so let us go add that field, and then it won't complain anymore. So basically, we added a chrono as a feature flag for Diesel, and also added the chrono create itself. This is why. So we could do seemingly simple that. So essentially now we have let's do this again. Might have to restart the Rust analyzer. Happens sometimes. Let us see. This is restarting. Oh, we're getting some errors. Oh, right, of course. So we need when we go to insert a few records now, we have to you know, because it's not null, for the created at, we have to generate a timestamp. So what we can do is we can say something like that. And I'm just using this something called naive UTC. So all I'm just ignoring time zones, but I'm just saying that whatever the UTC time is, put it in there, because I'm just going to assume all the time is UTC. And then we can just add a created add field, and then the insert should stop. Oh, actually, we are not doing this. Oh, we don't need this. Okay, so I think it should work now. I mean, appreciate, like, nothing really has changed. It's just that we've added the migration, and then it should just work. I mean, there's like 2, I think, fields. So here we can say the CRUD operations for data table are done. And I think we had a to-do here somewhere. This one. Oops. So I think it was update. Why did I delete the to-do? Oh, here we go. So delete last record. So I remember now. So what we wanted to do with delete last record is actually, instead of ordering it by data ID, whatever table ID, we want to do created at, and we want to do ascending. So ascending means that essentially, let's see, the TLDR is, it goes from oldest to newest. So we're just getting like the newest item, and we're just saying that just grab the whatever the sorted, so that it's from oldest to newest, and then wait, ascending order, which means that the lowest value, the highest for dates or timestamps is from the oldest to the newest. So the newest is going to have the biggest number, and then it grabs the first one, which is going to be the oldest. So this is deleting. They actually want the opposite, actually. So we want desk, which is descending, and we want highest to lowest. This is not a very ergonomic way to think about it. This is from newest to oldest. So we get the newest one on the very top, we grab it, and then we can just delete it. So I mean, what we had before was actually not the last, but the first. So okay. And then the last record, the rest of the code is unmodified actually. So here, if we run it, it should just delete this record, whatever, the max banana, which is probably the, you know, when I insert records, I think it would be prudent to not only display, you know, the let's see, print the records that were inserted. That would be nice. So we can say for, actually, where's the vec? Let's do this. Let records equals, do that, and then let's do this. Records, oops, records, and what happened here? What is this? Ampersand vec. 1 second. Let's see. I think I'm replacing the vec with this, so that should do the trick. I mean, so we do this and we do that, and it should just work. And then we can say for record in records, we can just grab, actually, there's no need to do this. We can just say record dot data. Okay, and then there's actually, we also have created at, which is a new one. So to do created at, I want to print like a human readable format. So I would like to make this, where the heck is this? Oops, lib.rs. I'm just gonna make a shared function in here, call it format timestamp. This is shared functions. So, and all that does is it just does a human readable format. So I can do something like format date time, and just need to pull it in. There you go. So now the records that are inserted, I mean, it's should have done this one. There we go. So we go inserted 2 records, the Lucy Cherry something, whatever, Lola Cherry something, and then Lola Cherry got deleted, which is just to confirm that this was the last thing that got inserted. So there we go. Now it works. And then what we can do is let us commit this. So this will be with altered table. And I think, yeah, that's good. Now let us do the automatic migrations, actually. I think this is a good time to do the, before we get too far. And then the last thing to do would be to implement the similar kind of thing for file operations. The only difference being that we're going to be essentially grabbing vec of U8s rather than text because of binary data. So in order to do the migrations, this is kind of like boilerplate, if you want to think about it. So essentially we have these imports, and we use this embed migrations macro, and it is in here for automatic migrations. And essentially what we do is we say there's just one function we need to run, and that is this one. It's called, actually let's put this underneath main. Let's say, let's see, try run migrations, and I think we just call, so the thing is we need a connection to run, no, do we? Yes, we need a connection to run migration. So the first thing we do is that, so we can say run migrations when the program starts. This is perform CRUD operations in the data pay, and so here we're gonna do, and that is not working. Why? Oh, I see. Right, because there is no into diagnostic for it. So here we can say if try migrations errors out, then we're just going to bail, because we can just say fail to run migrations, and we're going to say oops me yet bail failed to run migrations. I mean, it's kind of redundant, but we can just do this. So if the migrations didn't work, we just bail. So this should just work. So it doesn't, it's like, it doesn't, it's almost transparent. This is like one of the coolest things. So here we can say, let's say add auto migrations to, add auto migration run at start of program. Oops, so that takes care of that. And I think we have one more feature left, and then, okay, now that auto migrations are complete, we can actually wrap up by finishing the file table operations. So we can say file table operations, insert a few records, and I think Copilot will be generating most of this for us, because I don't think anything is appreciably different between the two. So let's do this. See, insert a few records. I think same kind of thing we do. Let's say file. So, oops. So here we can have it generate that, and then I'll fix them all in one go. Okay, generate that, and then here we can just return basically we're gonna do yet result nothing, and here we're gonna say okay, and then that's gonna be an import. All right, so here we're gonna do the same kind of thing where actually there's one thing we need to do is we need to I mean, it's not a big thing, but we need to actually we need to do a couple things. We can do this, and to diagnostic this one. This is just boilerplate stuff. That's why I'm kind of glossing over this. So let's put this here. Okay, so try read bytes from file. It just reads whatever the file path is into a bunch of bytes, and then it goes get SHA for those bytes. So that way we don't have to display the bytes over and over again. We can just calculate the SHA. The SHA is the same, then the bytes are the same. That's essentially the thinking behind that. And also, I wanted to show this other thing for SQLite connection. Where is it? So connection. There's actually a couple of ways. Oops, not MySQL, SQLite connection. Where is it? There it is. So there's actually 3 different ways of, I kind of glossed over this in the main program where we did database URL, which was just a string. Like there's a bunch of different ways we can create this this connection. It can be like what we did. It could be a URL, like a file path, and it can also be : memory : which is an in-memory database. So that's good to know. And then this is, let's see, form. Okay, so let's see. So if we run, okay, so here we have, let's see. So first we're gonna do just to be kind of like, we need to get the bytes from somewhere. So let's do this. Let's get the blob, which is the try read bytes. That's that function we just got. And this is going to be pretty uninteresting. We're just going to say the file. Oops, the file name to read is just going to be cargo.toml. So basically, we're just going to read the cargo.toml, and that's going to be the and then, oh, actually, we need to get a timestamp as well. So I think that was just, yeah, the naive UTC thing. And then we have, let's do this. We're going to generate some random IDs. Then we're going to make some random records. And this one is, I'm kind of flying through this because it's pretty much the same as what we've seen so far. And here we're just going to do let Copilot handle this. Net num records inserted. And this one is going to be schema file table values new records execute connection. Oh, and this one, the reason it's airing out is because that prelude, we need to bring that in. And then this one is also another import. And there you go. So here we have the this one, and here we can just say, oops, this one is the stylized thing from cross-term. And then we can also print the two records that were inserted. So here we can do something like, let's see, we can say for record in records, and yeah, that's okay. So we can say record data.length because that is a vec of U8, or we can do something much cooler and we can do something like this. So this is the record. So basically what we're doing is that we can SHA for bytes is data, and here we can do something like that. So essentially we just grab the SHA for the bytes, and that way we don't have to display the bytes and we know what we inserted. So, and here we're making the insertions into the where is it? We are making the insertions into the file table. So if I run it, it goes, oh, which one? Inserted. Actually, we should make this a different color. Let's see. Magenta. Okay, that works. Okay, so inserted number of records inserted in the file table is 2, and then Riley Kiwi. Then there's a SHA, so maybe we can make this a little bit less. Say SHA, and then let's run this again. Yeah, so we got our SHA, which is then quotes. Actually, I can make the SHA a different color or something. Whatever. And then, so now, there we go. So we have the SHA is the same, 2 1 something 6 9 2 1 something something 6 9. It doesn't change. If I do it again, the SHA is going to be the same. So that's awesome. And this is the human readable string around 9:46 p.m. UTC on November 15th. So that's all chrono stuff. Let us do the update first record. This should be pretty straightforward actually. So we can say, it's almost exactly like what we did with the other one. So we say maybe first record. We get that, and we say if let sum, then print that, else print that. So there's nothing to display. And let's see, we say we go to the file table. Actually, let me just import this so it's a little bit more easy to read. So file table, that's the import up there. If you see file table. So so here we're like, okay, from the file table, get the first record. It may or may not exist. If it does, then do the same thing, append it, and then just like we did before. And Copilot is doing an amazing job just taking care of it. So here we can say let maybe last record, and then we can say same thing. If we have a record, go ahead and delete it. Otherwise, say there's no records found. Let's double check. File table, find the last record ID and the last record. Okay. Yep, sounds good to me. And then print all records. That should be pretty straightforward as well. So there's all our records, and then we go and then for record and all records. There you go. And this one is pretty nice. It's doing the shopping with the backticks and everything. So, and there you have it. That is the data table portion done. In Copilot did the whole thing basically, and it knew that what the difference was between the two of them. And yeah, so that basically is a tour of the Diesel and Rust. I'm gonna, when I post this video, I will have a link to this this repo in the description. I'm also going to publish an article on Developer Life. It's basically just a copy of this. This is the article. It's just not hosted on Developer Life yet. I'm going to take this markdown, put it on Developer Life. So yeah, thanks for watching. If you enjoyed this video, please give it a thumbs up and subscribe to the channel. And I have a bunch of really cool content on the horizon as well. I'm planning to do a whole bunch of stuff around object-oriented programming and design, or design in Rust, how to use the trait system and subtyping variants and all that stuff. And then I have a whole host of other, I think even hardware reviews I'm planning to do, System 76 desktops and ThinkPad laptops for Rust development with Ubuntu. And then I'm also going to do a series on System D. Been doing a bunch of stuff around that lately as well. So yeah, a lot of interesting stuff coming for those of you that use Ubuntu, and a whole bunch of other Rust stuff as well. So yeah, let's see what else we got. I think I said subscribe and thumbs up. And yeah, if you haven't already, check out Developer Life, and you can join our newsletter there as well. I don't really post that many, maybe once a month. And yeah, so thanks for watching, and hope this was useful. Also, we have a Discord. If you have any questions, thoughts, comments on the content, if you want to see something interesting that I haven't covered yet, please, I'll put a link to that Discord in the description as well. So thanks again, and have a great day, and I guess you'll see me in the next one.